Okay, when it came out, direct vent was like a new term. Nobody even knew what that meant. Okay, now direct venting is the norm. You're not using a chimney, you're venting through a hole in the side of your house. So, many years ago, I would say almost 15 years ago, we came to market with this. We sold a lot of these, and we are still selling a lot of these, but we're really not known as a furnace company. We're known as a water heater company. So we said, well, let's tell the story here at this show. This is a Rinnai direct vent furnace, okay? It's small, it's compact, it doesn't have ducts, it looks nice. It's made in Japan. It's made in Japan because they have very small houses and their gas is expensive, so they needed a small unit. But for the American market, they said, hey, this will work for your homes too, we'll just make you some bigger units. So we have units up to 40,000 BTUs. So we have this small unit that mounts in one room, but you're like, okay, how's that gonna heat my whole house? I got a bedroom down here, my bathroom's down there. What the engineers have figured out over the years, or even before, initially, they said, yes, what happens is the room that you mount that unit in becomes the plenum of your furnace. Okay, that initial room, so you always want to try and put it in your biggest room, a living room, or maybe at the end of a hallway that connects to all your rooms. The unit starts up, and the beauty of it is it blows the heat out the bottom. It doesn't blow it out the top. Our competition blows it out the top. We blow it out at the floor level. So you can see the hot air, the red streak coming across the floor. That air temperature is maybe 80, 85 degrees. That feels really good on your feet, okay? So yeah, it's hot down at the floor. That's really where you want the heat, not in your face. What it does, it then begins to fill this room with air. The air temperature starts to equalize out at 68 because we don't sense the supply temperature, we sense the air coming back to the unit. So the unit's pushing out and taking back. It's continually looking at that returning temperature. So it knows what the temperature of the room is. We don't need a thermostat over here or over here. We know that the air coming back is going to be the temperature that the room is at. Okay, and that temperature is connected to a computer which does a bunch of other things that I can't even explain. It speeds up the fan, it sends a burst of hot air out, then it times how long that hot air comes back, so it actually knows the size of your room. Okay, it's all done with logic. It's not just turn on a burner, turn on a fan, it heats, it shuts off. There's a logic circuit in there. It's all done with computers nowadays. So this room begins to pressurize. The hot air, or the heated air, then begins to migrate through the other rooms. Now granted, if the doors are shut in the back bedroom, it's not going to heat it. You've got to have your doors open. If you close your doors at night, which you probably will, you should have an air gap under the door. So you want to undercut your door maybe 2 inches. And or you can put in a wall register that will transfer the heat from this heated plenum into a room that's closed. So you want a high and low register. Now it's just a through port, it's not a duct system. Okay, so yeah, you have to put in a register here and there if you've got some isolated rooms. But this will heat a 2,000 square foot home. A large ranch with different bedrooms, it'll actually do a 2-floor home. I put one of these in a 3-story townhouse. I put it in at the bottom of the basement stairs. It heats the basement, air goes into the first floor, completely heats the first floor, and then the heat's right up to the 3rd floor. Granted, the bedrooms are running about 2 degrees cooler up there, but it's because really she needs about a 70,000 BTU unit, and all we had is a 40, so she's like, I don't care, it's still cheaper than electric heat. Okay, her electric heat bill was unbelievable. Since we put this in, it's been a wonderful thing. She actually had a monitor unit in there before, and I replaced it with one of these. Okay, so we knew it would heat the space to her likings. Okay, so we can do, normally in that situation, I would say 1 in the basement to heat the first 2 floors, and then 1 on the 3rd floor for the very high bedrooms. But we have condominium complexes that are 2 stories, 1 up, 1 down, no problem. The beauty of it is you don't need ductwork. You don't have a big fan blowing dust around. It's comfortable. The way it heats is it's continually blowing out heat slowly, just like a wood stove. It radiates out. It just doesn't come on and blow heat and then shut off and you got nothing. It's on all the time. So you can see from the slide here, this is a hot air furnace. Hot, cold, hot, cold, hot, cold. This is a Rinnai unit. Warm, comfortable, always. Okay? Because it's continuous run modulating technology. There is no category for that furnace. It doesn't fit into any testing lab. There's no test for it. So we could never really compare ourselves to a furnace because they test by an AHRI standard, and these aren't considered AHRI, so we never really fit in a category. And it is considered a mid-efficiency unit. It's like 84%, and we're trying to compete against condensing furnaces that are 90 plus. So we said, okay, we'll do our own test. So we found a home in Canada, up near Ottawa, very cold. For 2 weeks, we ran the condensing furnace, and for 2 weeks, we ran our Rinnai unit. And we had sensors in all the rooms, in all the bedrooms. We monitored gas usage, and we monitored electrical usage. Now, we didn't want to sway the number. We didn't want to say, well, it ain't that great, but we'll tell them it's great anyway. Because that would be overselling the product. You'd put one in and say, hey, you told me it was great, it's not great. So these are actual numbers. Okay, these are actual numbers. And what we found was we actually were able to maintain a higher temperature in 7 of the 8 rooms than the condensing furnace. Even with the condensing furnace running all the time with the thermostat cranked, they could never get the far back bedrooms warm. Because the blower comes on, it pressurizes the room, and then nothing happens. Stops moving air. So we could heat those rooms, 7 out of 8 of them. We maintained them no lower than 68 degrees in 6 of the 8 of the rooms, whereas the central furnace did not. We have a chart where they actually dropped down to 66 and 64 degrees. But those back bedrooms were going down to 64. How can that be? We are only 82% efficient, gas burning wise. They're 91%. But what balanced us out with cost savings was that the electricity cost, and we use 77% less electricity. Okay? So to run this big blower, it costs a lot of money, bottom line. Granted, they are becoming more and more efficient, but we were only 3% over the operating cost of a 91% efficient unit. So you thought you bought a high efficiency unit, you paid a lot of money for it, you had a big ductwork system put in, and now here we come along with mid efficiency, no ductwork, and we're only 3% under what they promised for about half the money. It really is an amazing product. Amazing what we've done with these things, especially in Maine, New Hampshire, and Vermont. This thing has sold in some of the coldest locations, some of the draftiest homes, and we've had the best results with it. You can go on any website, any consumer report, you will not find a report that says that Rinnai unit didn't work. They all work. Everyone's comfortable, everyone's happy, low fuel bills, low electricity. And here's the actual data of each room. Okay, so above 68 average, and then above 68 with the furnace. Okay, so you can see because we're the red numbers, we're hitting our target more than the furnace. Bottom line, we're hitting our temperature more often than the furnace.